Let's create a DFA for the language W, where W contains at least 3 ones. So when we're creating a DFA, let's say for this language, what we're looking for is an input string. So the string is going to be made up of zeros and ones, as we can see by our alphabet, 0, 1. The string might look like 1, 0, 0, 1, 0, 1, 1, 0, just a bunch of zeros and ones. This is going to be our input string. What we're looking for is at least 3 ones. So we can see we have a 1, and then we have another 1, and another 1. This is 4 ones. Is that at least 3 ones? Yes, that's correct. But if we have an input string, if we have something like 1, 0, 0, 1, well, this only contains 2 ones, so then it would fail or reject. So when we're making this DFA, let's create our initial state. We always start with an initial state. And then what we want to do is keep a transition on 1 to a new state, and we're going to call this state 2. Now what this tells us is when we feed our string into our DFA, what we're going to do is upon seeing a 1, we go from state 1 to state 2. So we have the input string, for example, let's do 1, 0, 1. We have our first 1, so we start on state 1, and then we look at the first character, we see it's a 1, so then we follow the arrow with a 1 on it to state 2. And now we go to the next character. Well, we have a 0. Well, what happens if we have a 0? Well, logically, think about it. This string is not really affected by zeros. I mean, this language. If we have 3 ones, or we have 3 ones and then 5 million zeros after it, it doesn't matter. It's still the same. We still accept it because all we're looking at is the ones. We can have zeros anywhere we want. All we're looking for is at least 3 ones in the string. So therefore, if we have a 0, we shouldn't really go anywhere. We can just, stay in place if we see a 0. So what's going to happen is, say we go back a little bit. We have this first character, 1. We go from state 1 to state 2. And then we see our second character, 0. We just stay in place. We follow the arrow and stay in place. But now we want to count our next one. And what we can do is create another transition on 1 to a new state. We'll call this state 3. Now what's happening here is we have exactly 2 ones when we're on state 3. And we have exactly 1 1 when we're on state 2. We can try this for any string. We'll try this for 1, 0, 0, 1. We'll try this for 0, 0, 1, 1. Well, let's just do 0, 0, 1, 0. We'll try these 2 strings. So first we have 1, 0, 0, 1. So our first character, we go from state 1 to state 2 because we follow the arrow. Then our next character is 0. We follow the arrow, stay in place. Next character 0, same thing, we stay in place. Next character 1, we go from state 2 to state 3. We have exactly 2 ones. And so we basically jump 2 times. Now this is how we're going to count the number of ones, and this is what makes it really clever. Now say we have the string 0, 0, 1, 0. We enter and we are on state 1, and you'll notice we don't have an arrow for 0, so let's create one. Remember, zeros are not really relevant, at all, anywhere in this language, so what we can do is we can just, stay in place, loop on our own. And we can keep doing this we have the first character, and then we go to the second one, so our second character, we stay in place. And then we go to our third character, and then we go from state 1 to state 2. And then our last character, we loop in place. And we have exactly 1 1 in this string, and we end up at state 2, which means we have 1 1. So if we have 1 1 at state 2, and then we have 2 1s at state 3, well, if we create another transition, then we have 3 1s at state 4. And this is a jackpot because this is what we're looking for. We're looking for at least 3 1s. So we can have 3 1s, or we can have 4 1s, or we can have 5 1s, 6 1s. So it doesn't matter, just 3 or more. So therefore, if we reach the end, if we reach this state 4 where we know we have 3 1s, well then no matter what happens, we're going to accept because our string is valid. We can have 3 1s at the start, and then we can have whatever we want after. It doesn't matter because we know that we have these 3 1s at the start to accept. So what we can do is just loop on everything and stay in place. So let's create a loop for 0, 1, meaning if we encounter a 0 or a 1, we're going to follow this arrow and just stay in place. Because again, it doesn't matter what happens after this if we know we need 3 1s to get to state 4. And now something to check. I think this is our finished diagram here, but let's list out some things to check. So 1, we need accept states. 2, we need arrows. So for every character in our alphabet, we have an alphabet of 0, 1. We need an arrow coming out of every state for every character. So we need a 1 arrow and a 0 arrow coming out of every state. And then the third thing to check is testing. Just, write some input strings that you think might pass or fail it and see if it works or not. So the first thing are accept state. So this one's pretty simple. We know that if we're at state 4, that means we have 3 or more 1s. So therefore, we're just going to accept on state 4. None of these states are going to be accept states 1, 2, and 3, because we have 1, 1 at state 2. We have 2 1s at state 3. So this is never going to fit our criteria. So now our arrows. So on state 1, we have a 0 arrow and a 1 arrow. And on state 2, we have a 0 arrow and a 1 arrow. And on state 3, we only have a 1 arrow. We don't have a 0 arrow. We can just create an arrow to loop in place on 0, because again, 0 is not relevant anywhere in this problem. So we're just going to stay in place once we find one. And then state 4 has a 0 arrow and a 1 arrow. So that's perfect. Now let's test it for some strings. Let's write some strings. We'll do the strings 1, 1, 0, 0, 1. We'll do the empty string, so nothing. And then let's do one more. Let's do 0, 0, 1, 0, 1. So this first string here, 1, 1, 0, 0, 1, should it accept? Yes, because it has 3 1s. So this should accept. This next string, the empty string, should it accept? No, it should not, because it has 0 1s. We need at least 3. Now this string here, 0, 0, 1, 0, 1, should it accept? No, because we have 2 1s. So let's send this string through our DFA. So we start with our first character 1. We go from state 1 to state 2. And then our next character 1, we go from state 2 to state 3. And then on 0, we loop in place. So we stay at state 3. Then our next 0, we loop in place again. And then on our final character 1, we go from state 3 to state 4. And we end up on an accept state, which means we're going to accept. And this is exactly what we wanted, because we want to accept here because it has 3 or more 1s. Now on the empty string, we reject. So we enter our DFA, and then we have no characters to feed into it. So we don't go anywhere. We just stay on state 1. And this is not an accept state, so we're going to reject. And that's what we want. Now for this last one, we start our DFA. We have a 0, so we're going to loop in place. And then we have another 0, so we're going to loop in place again. Then we have a 1, so we're going to go from state 1 to state 2. Then we have a 0, so we're going to loop in place again. And then we have a 1, so we're going to go from state 2 to state 3. And we're not on an accept state, so we're going to reject. Perfect. This looks like a valid DFA for the language, W where W contains at least 3 1s. If you have any questions, please feel free to comment down below, and I'll try my best to answer. And I hope this made sense, and best of luck with whatever you're using this knowledge for. Thank you.